All right, so today we're going to cover 3.4 and 3.5. Couple of things I want to talk about. I'm going to go, the review that it was supposed to be due this Sunday is not going to be due. We're just not going to be able to get to it. We're going to do it on Tuesday, so it'll be due next week. So I'll change that in Math Lab, so you'll see that it'll be due next week. So what we're going to cover today is 3.4, talking about graphing using the slope and y-intercept. And here are the steps that you're going to take for every single one of these problems. Steps of graphing lines using the slope and y-intercept. The very first step sometimes will be done for you. It says to put the equation in y equals mx plus b. In other words, get the y by itself, because if you get the y by itself, the number hooked onto the x is the slope. The number not hooked onto the x is the y-intercept. So that's why you want to get the y by itself. Once you do that, you'll know your slope and y-intercept from this equation. The first thing you're going to do on the graph is put a point on the y-intercept. Whatever the number is that's not hooked onto the x, you're going to go to the y-axis, which is the one that's up and down. Okay. The one that's up and down, and put a point on it. Yeah, we're starting all over on 3.4, but then we're going to do 3.5. Okay. So you put a point on the y-intercept. Then you're going to count out the rise and the run, starting from that point that you just put on the y-axis. That's where you're going to start your counting. You'll count your rise and your run. Wherever you end up after you count those two directions is where you're going to put your other point. So you have a point on the y-axis, count out your rise and run, put another point, and then you'll connect those 2 points to draw your line. Okay? Got it? I'll wait on you. I'll wait on you. I'll just pause it. Didn't I write these? You probably. So this right here, y equals 3x plus 1. The slope is the number hooked onto x. Since it's a whole number, I think of it as over 1, because this 1, you'll see, is very important. The y-intercept is the number not hooked onto x. So it's positive 1. So now I'm going to go to my graph. The very first point you're going to put on your graph is you're going to go to the y-axis, this axis right here. Your point is going to be on it. It's going to be on that axis. It is not going to be out here in any open areas. It's going to be on that axis at whatever number this is. So since this is positive 1, you're going to go to the y-axis and go up to positive 1, and you're going to put a point there.
Can you let them know? In my lab, it be half.
Yep. So we're going to be careful. Something that we didn't notice until we started working some of these in my labs on Tuesday is some of their graphs go by halves. So you need to make sure that you are on positive 1 and not 0.5.
And it's going to show you the corner.
It'll show you, that's right, up here in the corner. It'll show you the 1. The x needs to be 0, and the y is whatever that is. So you're going to be at positive 1 on the y-axis. After you put that point, now the next step was to count out the rise and the run, starting from this point that you just put there. So my rise and run, I'm going to, since it's positive 3, I'm going to rise up 3, and then I'm going to run to the right 1. That's why that 1 was important. It gives you how far you run. So let's start here. Again, some of the graphs go up by half. So if you're at 1 and you rise 3, where should you be ending up? If you start at 1 and you go up 3 more, where should you end up? You should be on the 4, right? If I start here and go up 1, 2, 3, then I'm actually at 4, right? Since I started at 1, I rose 3. Now what's that? Don't put a point there. You got to do this move and this move. So I'm going to rise 1, 2, 3, and then I'm going to run to the right 1. So once you do that, Math Lab, since you've already told it that you were going to draw a line, because remember, you got to tell it what you're going to draw before you can plot any points, it's going to automatically connect those points for you, because once you plot that second point, that draws the line. Okay? Let's look at number 3. Y equals 8/9 x minus 3. All right, is the y by itself? It is. That's good news, right? That means we actually get to skip step 1 because the y is already by itself. I'm going to move on to step 2. Well, before that, since it is by itself, I can now identify the slope and the y-intercept. What's the number hooked onto the x here? 8/9. So that's going to be my slope. Good. Your y-intercept is the number not hooked on to the x, which is -3. Okay, so what's the very first point that you're going to put on your graph? What goes first? Which one of these do I need to be looking at? That -3, right? You put a point on the y-axis at that -3. So here's your y. You go down to -3 and put a point. So what should your little thing say up here in the right top corner? What should be this number right here in the y spot? -3, and that one will be 0. So that's going to be your first point. Then I'm going to count out my rise. Since it's +8, I'm going to go up 8 and run to the right 9. Where do I start my counting from? All right, I'm going to start here and go up 8, run 9. So be careful. I think this may be one of the graphs that goes up halves, which is ridiculous. So if I go up 8, I'm going to go up 1, 2, 3, 4, 5, 6, 7, 8. So if I go up 8, and then I'm going to run to the right 9, and I only put 9 hash marks, so I'm just going to go over to the end of it. So there's up 8, over 9, and then connect. Another way you can make sure you're growing up the right amount is type in where you're starting. Where am I starting? Where did I start here? I started at -3, right? and I rose 8. So I went positive 8. You can type that in. If I start at negative 3 and I go up plus 8, here's where I should end up. I should end up on the 5, right? So that's how I can kind of help myself. If I started here at negative 3 and I needed to rise 8, 1, 2, 3, 4, 5, 6, 7, 8, I should end up, my Y now should be 5. So you can kind of help yourself out there. And then if you run to the right 9, you should end up at with the X being 9. Okay? Let's look at number 4. Yeah, I think it's only tough. Negative 5x plus y equals 2. We didn't do them in class, but I think you might have did it on your homework.
Negative 5x plus y equals 1. So this might be
Yours,
my
that's what yours probably did on. Yep.
Okay.
So, is the y by itself in this equation?
Yes.
Is it by itself? Or is there something on the side with it?
It's by itself?
Uh-uh.
Oh, yeah.
By itself means, if I'm looking at my
Right.
equal sign, is there anything on the same side of the equal sign as the y? And there is. That negative 5x is on the same side of the equal, which means I need to get rid of that. You can't choose your slope and y-intercept until the y is by itself. So how am I going to get rid of minus 5x? Right. If I add 5x here, I have to add 5x here. Get rid of that minus 5x. Now I have y by itself. There's my equal. Now, here's something that's very important. When I am working on this other side, this 2 and that 5x can't go together. Why can't they go together? Why can't I put that together and call it some kind of 7? What does 1 have and 1 doesn't? That x. That means you cannot add those two things together. They're not like terms, which means they just both need to come down on that right side as 2 separate terms. You're going to have a positive 5x and a positive 2. It doesn't matter who's in front of the other. You just need to have a positive 5x and a positive 2. So let's see. If I put the 5x in front, I'll have 5x and plus 2, or you could have 2 plus 5x, however you want to say it. Now is the y on that side of the equal sign by itself. Now it is. So now I can take out my slope.
So it's going to be
And my y-intercept. What's the number hooked on to the x?
5, so it'll be 5 over 1.
Good. So if it's a whole number, go ahead and put it over 1, right? Because now we know that that bottom number of the slope tells you how far to run. So I've got to see it. What's the y-intercept? What's the number not hooked on? 2.
Okay, so y.
What's your y-intercept? Where are you going to put your first point? Positive 2. Right? So I'm going to go to, here's my y-axis. Your first point is always on that y-axis. I'm going to, here's my starting point. I need to go to positive 2. There's your first point. After that, what do? Now I count out my rise and my run. What is my rise?
5.
What is my run?
1. So you're going to go up to 5 and go over 1.
Not up to 5. You count up 5 from here. So I'm already at 2.
Right, so 2, 3, 4, 5.
No, you count up 5 spots. So if I start at 2
Oh, 1, 2, 3. Okay.
and then go up, look, type it in your calculator. If you start at 2, starting at 2, and I go up 5, so plus 5, where are you actually going to end up? At 7. That's exactly right, because I start here.
So 1.
I'm not starting at 0.
So you're going to start at 2, 1.
I go 1, 2, 3,
Right, you don't count the
4,
red dot.
5. No, you don't count the red dots. Oh, I see what you're saying.
Yeah.
No, you don't count. That's like 0. That's like saying no. So
Okay.
count starting here, like watch.
1, 2, 3, 4.
1, 2, 3, 4, 5. Then what do I do right here? Don't put a point. What do I got to do first?
1.
Run 1. So up 5 over 1. Connect.
Ooh, that's a positive, ain't it?
Yep. How do you know about looking at that line that it's positive? What does it do?
Because you,
From the left side to the right side, it goes up, right? We know we know the direction of slopes now from Tuesday. All right, number 5 says x plus 4y equals 16. All right, this one has a lot of work to do it because the y is not by itself. Remember, here's what I want by itself, just y. The number hooked onto the y doesn't go away until the last, right? The number, if it's hooked on, it doesn't go away till the end. So I need to make this positive x go away, which means I need to do what? Subtract x.
so basically x is 1.
Right? So here's my equal sign. I still have a 4y over here.
And you're going to drop down to 16.
Right, and what else?
The x.
Right, I still have these two things over here. I just put them separately, and it doesn't matter who goes in front of the other. I'm going to put the negative x up front plus 16. But you can put 16 minus x. Right? These two things just have to come down because they can't go together. They're not like terms. So now, to get y by itself, what do I need to divide by? 4. Everybody by 4. So y?
Oh, so your slope going to be negative 1/4.
Good, because that's a negative 1 in front of that x. So I have negative 1 over 4x.
And then your slope going to be 16 over 4.
Which is what? What is 16 divided by 4? That'll divide 4. So now that we've put it in, y equals, here's your mx plus b. So the slope is the number hooked onto the x. So what will that be?
Negative 1/4.
Good. Negative 1/4.
And then your y-intercept is 4.
Y-intercept, positive 4.
I don't think you got to work these out.
So, where are you going to put your first point? On your y-axis at positive 4. So come to, here's your y-axis. If I start in the middle, I need to go up to 1, 2, 3, 4. So positive 4. Now, here's something that we haven't had before. This time our slope is negative. When you have a negative slope, just turn your rise, instead of going up, go down. You're still going to go to the right for your run. So in other words, a positive slope you can always go rise, up, run, right.
Oh, I was right there.
A negative slope, you can always go down and right. So really the only thing's changing is whether you're going up or down. Positive, go up and right. Negative, go down and right. So what do I need to do? Here's my run, rise and run. I'm going to go, where am I starting from? I'm starting from this red point.
Right.
I'm going to go
Dang.
down 1, right 4. Starting here. Down 1, right 1, 2, 3, 4.
And that's a negative.
Yep, that's a negative slope. Because look how it ended up. Go look at, see how your slope directions are? Negatives go this way, and look how that's going. It's going that way. It's not as steep, but it's still going that way. I'm going to put another one of these on the board and let y'all try it. All right, try that one. X plus 5y equals 20. Okay, so let's solve this one for y first. So getting the y by itself, I need to get rid of x again. So I'm going to subtract the x. So now I have 5y equals, it doesn't matter who goes in the front. I'll show you why it doesn't matter. I have 20 minus x. So say I put it the opposite way I did from the last one. Still doesn't matter. Yours is going to end up being exactly the same because what do I have to divide by? 5. So here's my y equals 20 over 5 is 4 minus, what's in front of that? Negative, you're fine, negative 1/5 x. So if you notice, my x ended up in the back and this ended up in the front. It does not matter because what number is hooked onto x? That's still my slope.
Right. But I put a addition sign instead of
In front of the 4 though, right? You have negative 1/5 x plus 4, which is the same thing. My slope is the number hooked onto the x, which is negative 1/5, same as yours. My y-intercept is the number not hooked onto the x, which is 4. So put a point on your y-intercept, which is at positive 4. So y-axis, go to 4. 1, 2, 3, 4. Count out your slope. Since your slope is negative, I'm going to go down and right this time. So I'm going down from my y-intercept. Down 1, right 1, 2, 3, 4, 5. And then the last one in this section says graph the line passing through the given point and having the given slope. So it doesn't give us an equation like this, but it does tell us a point to put. It says there's a point at 0, negative 3, and the slope is negative 2. Anytime you see an M, that stands for slope for some reason. So it tells me the line goes through this point at 0, negative 3. Well, if your line goes through that point, go put that point on the graph. So the point goes through 0, -3. So remember, you've got your little thing up here. You just need to move it into where it says 0, -3 and put a point, right? So that means my x coordinate is 0, my y coordinate is -3. So if I start from the origin,
go down.
right, because what does the x being 0 tell you to do left and right? Nothing. That's right. So go left and right, nothing, down 3. So it goes through that point.
And then you got to plot 2.
Now, what's the slope? Since it's a whole number, you think of it as what? That's your slope, right? If it's a slope, you want to see a rise and a run.
Yeah, so you're going to go down and over.
Right, because this is negative, so I'll go down and right. Starting from this point. Down, 1, 2, right, 1.
So, hold on. So,
start at the point that you put.
Right, and then go down 2, right?
Down 2.
And then go over,
over 1.
Okay.
All right, 3.5, last section of this chapter, which means your test is next week, but we're not going to do the review until Tuesday.
Okay,
Tuesday, we're going to do the review. I'm going to take it. It says in Math Lab that the review is due this Sunday, but it's not going to be due until, I'm going to change it to next Sunday. Okay? Because I don't want to rush this. It's something we can just rush through.
No, you can't. I gotta get the sliding down. I appreciate you, Miss B.
Yeah, I'm not going to rush through this. This is something that's important. Okay, before we get into 3.5, there's some notes that you need to take into account about parallel lines. And perpendicular lines.
Oh, Lord.
Let's just see what those two kind of lines look like. Parallel lines are the ones that look like that. They run right next to each other. They don't ever get any closer together. They don't ever get any farther apart. They surely don't ever cross, right? They are parallel lines. They do not cross ever.
Okay, wait, they do not cross.
And that is because they have the same slope. They rise and run exactly the same. Perpendicular lines.
They don't have the same slope.
No, they sure don't. These are perpendicular lines. Not only do they cross at an exact T, at a 90-degree angle. So not just because lines cross doesn't mean they're perpendicular. Like for instance, those lines cross, but they're not perpendicular, right? They don't cross at an exact T. This right here is not like a T-shaped angle. Okay, so just because lines cross doesn't mean they're perpendicular. They have to cross in a very specific way at an exact 90-degree angle. The reason they cross like that is because they have what's called negative reciprocal slopes.
And reciprocal means different.
And reciprocal means the flip. We're going to talk about examples of each of these. Same slope, parallel line, same slope means their slope is the same exact number. Same sign, same everything. So like examples of same slopes would be they would both have slopes of 1/2, or they both have slopes of -3. They're exactly the same number, same sign, same everything. So same slopes are not as hard to come up with. Same exact number. What negative reciprocal slopes mean? The negative part of this means their signs have to be different. When you're talking about perpendicular, one slope is positive and one slope is negative. They have to be different from each other. Reciprocal means flip. So we're going to talk about what that means. We'll just say, I'll show you some examples of negative reciprocals. 2/3 is the negative reciprocal. Let's see, if I give it the opposite sign, so if this one's positive, what would the other one need to be? And then flip that upside down. Those are negative reciprocals of each other. That's what makes lines be perpendicular. There's a couple of things that can be tricky about this one. Let's do another couple of examples. So if that's one of the lines, slopes.
So positive 7/6.
Right. Opposite sign, so now the other one's going to be positive. Flip that upside down to be 7/6. Good. So that's another example. Let's look at something else you may run into. 1/2. What's the other sign? So what's this one's sign going to be? -2/1, which is what? What is -2/1? That's just -2, isn't it? So 1/2 and -2 are negative reciprocals of each other. What if the slope of one line is -3 and the lines are perpendicular? What would the slope of the other line be? What sign would it have? Positive. What do you get when you flip a 3? Think of this. If it's a whole number, it is automatically over 1. You just don't see it. So if I flip this, give it the opposite sign and flip it, I'm going to have positive 1/3, right? And so if yours is a whole number, think of it as over 1 so that you can flip it. Okay? So let's go to these problems. Now that we have examples and we know exactly what parallel and perpendicular mean, we should be able to go through these pretty simply. Parallel lines, again, same slope. Perpendicular lines, opposite sign with the flip. Number 1 says M1 represents the slope of line 1 and M2 represents the slope of the line 2. Indicate whether the lines are parallel, perpendicular, or either. So the way it gives you a slope of line 1 is something.
This number 1? Okay, good.
So it gives you, this means slope of line 1 and slope of line 2. It says slope of line 1 is -6. Slope of line 2 is -1/6. And then it's going to be multiple choice for all of these. They're either going to, it's going to say parallel, perpendicular, or neither. You're going to pick one of those.
Oh,
So let's see, are they the same exact number?
they're perpendicular.
Now hang on. Are they the same number?
Well, yeah,
No,
no.
they're
no.
not the same exact number.
So they need it.
Why are they neither? Why are they not perpendicular? What do they both have that makes them not be perpendicular? They both have the same sign. Remember, perpendicular lines have to have one positive, one negative. They are the flip of each other. They just aren't one positive, one negative. So that's why same signs would mean these numbers would have to be exactly the same. That would make them parallel.
So like on this one, it's -4, so it's neither parallel or neither perpendicular.
Those are the same. Are they the same number?
Yeah,
So what are they?
they're gonna be perpendicular.
What lines?
Parallel.
What lines have the same slope? Parallel.
Okay.
If they're the same exact number, so is that your number one?
Yeah.
See, mine would be neither. Her number one came up as this. Slope of line 1 was -4. Slope of line 2 was -4. They have the same exact number. That would mean they are parallel. My number one was
Neither parallel, neither perpendicular.
right, because they aren't the same number. One was -6 and one's -1/6, so they're not parallel. Then I need to say, okay, now I need to check to see if they're perpendicular. They are the flip of each other, but they don't have different signs. So that's why this would be neither. All right, number 2, same thing. There's a bunch of these that are just going to give you different numbers. Number 2, the slope of line 1 is 2. The slope of line 2 is 2. Do they have the same slope? Are these the same exact number? Yes, which means they are parallel.
And then this one is perpendicular. Because it's a positive. It ain't.
Are they the flip?
What you mean?
If they're perpendicular, they're going to have not just opposite signs and the flip of each other. I'll put that one up here. What is it? 8 and -8? So, if these are your slopes, 2 things it's asking me. Are they parallel first? We'll decide that first. Are they the same exact number? No, one's +8, one's -8. That's not the same number.
No.
So then you're saying, are they perpendicular?
No.
Do they have opposite signs, which is the first thing you look for?
Yeah.
Yes, they do. But what else do they have to have besides opposite signs?
A flip.
A flip. So the one of these would have to not be 8. It would have to be 1/8 to flip it.
So it's neither.
So that's no also. So that's why that one is neither. It's not parallel and it's not perpendicular.
Because you got the flip.
They're right. They don't have the flip. They have one of the things checked. They do have opposite signs, but they don't have the flip of each other. All right, number 3. I'm going to leave that up there because that's kind of what we're checking out on every single one of these. -3/4 and -4/3. Checking first, are they parallel? Which means, are these numbers exactly the same? No, they're not parallel. Are they perpendicular? Do they have different signs? Look at their signs.
No, they don't.
They don't have different signs, which means I don't even have to worry about the flip because the perpendicular has to have those things, right? It has to have different signs and flip. So this time, they are the flip of each other, so it has that part.
Mm-hmm.
They just don't have different signs.
Right.
So it's not perpendicular either, which makes it automatically neither. If you're not parallel and you're not perpendicular, you're neither.
Wait, hold on.
Yours
This one rounding.
Look at yours.
It's the same thing.
No, it's not.
Oh.
Yours do have the opposite sign.
Yes, those ones are big.
They're the flip, and one's positive, one's negative. Okay, so hers on that one was, what was your top one?
Negative 5/2, and then the other one is 2/5.
Okay, so when you were going through your checklist, are these the same exact number? Same exact number?
No.
No, so they're not parallel. Perpendicular, first thing I'm checking for in perpendicular is, do they have opposite signs?
Yeah.
Yes, so there's one thing it needs to have to be perpendicular. What's the other thing it has to be perpendicular? Flip is 5 halves. If you flip that upside down, is it 2/5? Yes. So that is perpendicular. So yours are not going to be the same exact as mine on this. Number 4. Mine.
Ooh, this one is parallel.
My number 4, slope 1 is 7, slope 2 is 7.
Parallel.
Are they the same exact number?
Yes, ma'am.
Yes, so they are parallel. And you don't need to check anything else, because if you're parallel, you're not perpendicular.
And I hate the little parts.
Yeah, I mean, you can't be both.
Okay, so this is kind of easy.
All right, number 5. Once you get the hang of it, it takes some practice, but once you practice.
Yeah. Oh, my number 5 is the same what we just did. On the 2/5.
It is.
Yes, come look.
Mine's this one.
It's the same thing we did.
Sure is. So, are these the same? Always check parallel first. Are these the same exact number?
No.
No, they're not the same
It's
number.
perpendicular.
So what 2 things have to be there in order for it to be perpendicular? First thing you check for is
A negative and a
a
positive.
negative and a positive. Doesn't matter which is which. You just have to have one of each, which I do have.
Right.
So then I go to the second check thing for perpendicular is 4/5. If you flip it upside down, what does it turn into? 5/4. So they have opposite signs and they are the flip of each other. So yes, they are perpendicular. Now, number 6 and 7 ask something a little different. It says the slope of a given line is 6. So it's telling you there's a line and its slope is 6. If a line is to be drawn parallel to this line, what will be its slope? If I am parallel, what will I have?
Another 6.
Another 6.
So mine gonna be
Whatever, if it says parallel, it's the same exact number. So if your slope is -4 and it's parallel, your slope is also going to be, it's going to be the same exact thing.
I need to write that. Okay.
Last one.
Yeah, check the answer for me. So it. Why?
Number 7, the slope of a given line is 6. So slope of the given line is 6. If a line is to be drawn perpendicular to this line, what will be its slope? So first of all, we're talking perpendicular now, right? Which means not the same, but negative reciprocal. which means if this one's positive,
It needs to be negative.
this one will need to be negative. And flip that. What do you get if you flip a 6? What is 6 over? I just don't see it.
1.
It's over 1. So think about that. Well, now you can see what it'll be. What do you get if you flip this upside down? 1 over 6.
So this one's gonna be.
So if your slope is -3, it don't need to be, it is negative, so yours needs to be the opposite sign.
3 over 1.
You gotta flip it.
One side.
So this is, yes.
Can you do another one? Cause
Yep. So this one, so say this question is the same, still out talking about perpendicular, but it tells you your slope of the line is -3. If I'm perpendicular, if this one's negative, what does this one need to be? Positive, so it will need to be positive, so we've established that. What else has to happen for it to be perpendicular? The opposite sign and flip this. What do you get if you flip a 3? 1 over 3, correct. And it's positive, right? Have to have different signs.
Okay, so.
I'm gonna totally throw you off.
You think I can get it though?
I don't know, we'll see. This will take me a minute. Say your slope is 1. And you want to be perpendicular, which means the sign will have to be the
Negative.
negative.
-1 over -1.
Oh no, you got it! Because why? If I think about this, if I thought, if this is 1, it's 1 over 1.
Right.
If I give it the opposite sign and make it negative and flip that, it's still 1 over 1.
Right.
Good. You should get a bonus.
How? What you say?
Okay, you should get a bonus for that. But yes. So let's try one more. Let's say still you're perpendicular. And 2/3 is the first slope.
So it's gonna be -3 over 2.
-3 over 2.
You just did that.
Yeah, I did. -3 over 2. Okay? All right, so let's talk about next week, and I'll send this out in an email and an announcement also, because next Thursday, I'm not going to be here, but I am going to do a video. So there will be a video. I'm not going to skip a lesson. I'm just not going to be live from 9:25 to 10:40 like I always am on Thursdays. So there will be a YouTube video in your week 7 folder for the start of chapter 5, which is what we're doing next Thursday. So it will be in there for you. It's just not going to be live. It'll just like you're watching it at home. Okay? I have a conference to be at next Thursday and Friday. So just next Thursday, I won't be here, but there will be a lesson. You just have to go look at it in your week 7 folder. Okay?
Okay, hold on.